I'm going to walk you through the integral of 1 over 1 plus sine x plus cosine x. This seems like a pretty tricky integral because it's not always straightforward what we have to do, but in most cases what'll work is that we can take the reciprocal of what's in the numerator or denominator to factor out this, this function and see if we get something that we are able to break apart and then integrate. So what I did was I went ahead and I looked at this function as follows. I decided to put a parentheses around the sine x plus cosine x, and I took the denominator to be 1 plus, and then sine x plus cosine x, and I multiplied that, the numerator and the denominator, by 1 minus sine x plus cosine x. And after you do all of the distribution, what you should get is 1 minus sine x plus cosine x, over 1 minus sine x plus cosine x, plus sine x plus cosine x minus sine x plus cosine x squared. And this is because we had to FOIL the denominator. We see that these two terms are alike, and so we can go ahead and cancel them out, plus and negative. And what you're left with is 1 minus sine x minus cosine x over 1 minus sine x plus cosine x times sine x plus cosine x. Now, I went ahead and I did the factoring on the side over here, just so that we wouldn't it wouldn't get so messy. But what we end up with is sine squared x plus 2 sine x cosine x plus cosine squared x. You have to keep in mind the identities, which are going to help you immensely once you begin to solve problems with trigonometric functions. And in our case, we know that sine squared x plus cosine squared x is equal to 1, which will become extremely useful in the next few steps. So we want to keep in mind that the negative sign is still carried over from the previous step. And on the inside, we can just go ahead and cancel these two terms. And what we're left with is 1 minus 1 plus 2 cosine x sine x. When you go ahead and do all this work, you get 1 minus 2 sine x cosine x. These two cancel, and you're left with 1 minus sine x minus cosine x over negative 2 sine x cosine x. At this point, we want to break apart the integral into three different integrals. And we're left with these three integrals. What we're going to do is, for the first one, it's going to require u-substitution, but for these other two, they're a lot simpler because what we can do is we can factor this constant negative 2 from the denominator as a negative 1/2 and bring it to the front of the integral, and we can also cancel out the signs on the numerator and denominator. The same applies in this case with the negative 1/2, and we can cancel the cosine x in the denominator. What we're left with is negative 1/2 times the integral of 1 over sine x cosine x plus 1/2 times the integral of 1 over cosine x plus 1/2 over 1/2 times the integral of 1 over sine x. We also want to keep in mind of this other identity, which applies to the sine x cosine x and not so much the 1 over the sine x cosine x, although it's the same thing. I kept it in terms of the 1 over sine x cosine x just because it's easier to see with regard to our function. What we should be left with is 2 times the cosecant of 2x. When we plug all this back in, what we're left with is 1/2 times 2 that we got from this identity of the integral of cosecant of 2x dx plus 1/2 times the integral of secant x dx, which we got from the 1 over cosine x, plus 1/2 times the integral of cosecant x dx, which we got from the 1 over sine x dx. Now, we're going to go ahead and do that u substitution for this integral specifically. We'll let u equal 2x so that the du is equal to 2x dx. We can divide 2 by both sides and get that 1/2 du is equal to dx. Plugging all of this back in, what we get is that negative 1/2 cosecant of u du plus 1/2 the ln of secant x plus tan x, which we got from the integral of secant x dx times 1/2. And then what we get from the integral of cosecant x dx is the ln of the absolute value of cosecant x minus cotangent x, and of course we have to multiply that by the 1/2 constant that we had outside of the integral. When we integrate the cosecant of u, it's going to be done in much the same way as these functions were, where you have an ln and the absolute value of two trigonometric functions. And what we get is negative 1/2 times the ln of the absolute value of cosecant of 2x minus cotangent of 2x plus 1/2 times the ln of secant x plus tan x plus 1/2 times the ln of the absolute value of cosecant x minus cotangent x. And using the laws of logarithm, we can go ahead and combine these two. Keep in mind that when we're adding ln's together, as we are in this case, what we can do is we can actually take the inside and we can multiply them. And then when we're subtracting, as in the case of this negative 1/2, we're just going to be dividing those terms. And this is sort of a visual representation of what that means. First, I went ahead and I factored that 1/2 to make it easier for us to see what we're going to be doing with the ln laws. And then what I did was I went ahead and I combined them in the way that I told you I would. You see how the secant x plus tan x and the cosecant x minus cotangent x are being added. That means that we can combine them into one ln, but we had to multiply them. And because this is a negative ln, we're going to go ahead and we're going to subtract, we're going to divide that entire term. And what we're left with is we're left with 1/2 times the ln of the absolute value of secant x plus tan x times cosecant x minus cotangent x over cosecant of 2x minus cotangent of 2x. Now, this is the type of problem that you can spend quite a bit of time simplifying, and it's not always super clear when you're done with the problem, but a good rule of thumb is to just do as much as you can to keep the inside of the ln as simple as possible. And what we're going to do is we're going to factor out these using the FOIL method in the numerator. And what we're left with is 1/2 times the ln of secant x cosecant x minus cotangent x secant x plus tangent x cosecant x minus tangent x cotangent x over cosecant of 2x minus cotangent of 2x. We can go ahead and use the identities of secant, cosecant, cotangent, and cosecant, all of the ones that we have here. And what we should get is what we have here in the numerator. And what we're going to notice is that a lot of these terms can actually cancel each other out, and we'll be left with an entirely different trigonometric function. We recall that everything that I went ahead and I put in parentheses here corresponds to the term directly above it, or at least close to it, in this order. And when we go ahead and cancel out all of these terms that appear in the numerator and denominator when we're multiplying them, our final answer should look something like this. It should look like the 1/2 times the ln of the absolute value of 1 over sine x cosine x minus 1 over sine x cosine x plus 1 over cosine x minus 1 over cosecant of 2x minus cotangent of 2x. And we can go ahead and revert this back to the cosecant x, and in this case it's going to be secant x. And what we're left with at the very end of our problem is 1/2 times the ln of the absolute value of 1/2 of sine of 2x minus cosecant x plus secant x minus 1 over cosecant of 2x minus cotangent of 2x, and this is all, of course, in the absolute value, and we can't forget our constancy.